Nebulae, these vast, mesmerizing clouds of gas and dust, are the cradles of stars and planets. But how would you know if you were inside one? Let's dive into the science and imagination of this cosmic scenario. First off, what is a nebula? Simply put, a nebula is a giant cloud of dust and gas in space. They come in various forms, such as diffuse nebulae, loosely shaped regions where new stars are born; planetary nebulae, formed from the outer layers of a dying star; supernova remnants, the remains of an exploded star; and dark nebulae, dense clouds that block starlight. So if you were to find yourself in a nebula, here are some scientific indicators that might clue you in. First, reduced visibility. Nebulae are composed of gas and dust, which can obscure your view of distant stars and other celestial objects, making everything look hazy or foggy. Next, spectral analysis. Using a spectrometer, you could analyze the light around you. Nebulae often emit specific wavelengths of light due to the ionization of gases like hydrogen and helium. Emission nebulae, for instance, glow brightly in the visible spectrum due to the ionization of hydrogen. Temperature variations are another clue. Nebulae can have varying temperatures. Some regions might be extremely cold, while others, especially near young stars, could be quite hot. Then there are magnetic fields. Nebulae often have complex magnetic fields. Instruments that measure magnetic fields could detect these variations. Lastly, chemical composition. The presence of certain elements and molecules, such as hydrogen, helium, and complex organic molecules, could indicate you're in a nebula. Now, let's stretch our imagination. What might it feel like to be inside a nebula? Imagine being surrounded by vibrant colors and swirling patterns of gas and dust. The light from nearby stars might create a breathtaking cosmic light show. Picture the ethereal silence of space. No sounds, just profound, almost otherworldly silence. Feel the weightlessness. Without a significant gravitational field, you would float amidst the cosmic clouds. Consider time dilation. If you were near a massive object like a black hole within the nebula, you might experience time differently due to the effects of general relativity. And finally, be wary of cosmic radiation. Depending on the type of nebula, you might be exposed to various forms of radiation, from ultraviolet light to X-rays. Proper shielding would be essential for survival. Planetary nebulae are among the most stunning and intriguing objects in the cosmos. Despite their name, they have nothing to do with planets. The term planetary nebula originated in the 18th century when astronomers observed these objects through small telescopes and noted their round, planet-like appearance. Formation and characteristics. Planetary nebulae form during the late stages of a star's life cycle. When a star with a mass between 1 and 8 times that of the Sun exhausts its nuclear fuel, it expands into a red giant. Eventually, the outer layers of the star are ejected into space, creating an expanding shell of ionized gas. The hot core of the star, now exposed, emits ultraviolet radiation that ionizes the surrounding gas, causing it to glow brightly. Key characteristics of planetary nebulae include size, typically about 1 light-year in diameter. Mass. The ejected material usually has a mass of about 0.3 solar masses. Density. They are denser than most other types of nebulae, with densities ranging from 100 to 10,000 particles per cubic centimeter. Lifespan. Planetary nebulae are relatively short-lived, lasting only a few tens of thousands of years compared to the much longer lifespans of stars. Structure and appearance. Planetary nebulae exhibit a wide variety of shapes and structures, often appearing as rings, shells, or more complex forms. This diversity is thought to result from interactions between the ejected material and the star's magnetic fields, stellar winds, and possibly the presence of binary companion stars. Some well-known examples of planetary nebulae include the Helix Nebula, NGC 7293, located in the constellation Aquarius. It is one of the closest planetary nebulae to Earth. The Cat's Eye Nebula, NGC 6543, known for its intricate structure and concentric shells. The Dumbbell Nebula, M27, the first planetary nebula to be discovered, located in the constellation Vulpecula. Role in the universe. Planetary nebulae play a crucial role in the chemical evolution of galaxies. They expel elements such as carbon, nitrogen, and oxygen into the interstellar medium, enriching it with the building blocks for new stars and planets. This process helps to recycle material within galaxies, contributing to the ongoing cycle of star formation and evolution. Our Sun is expected to form a planetary nebula at the end of its life cycle, approximately 5 billion years from now. As it transitions into a red giant, it will shed its outer layers, creating a glowing shell of gas that will eventually disperse into space. Planetary nebulae offer a glimpse into the future of our own solar system and provide valuable insights into the life cycles of stars. Their beauty and complexity continue to captivate astronomers and stargazers alike. The vibrant colors of planetary nebulae are a result of the ionization of different gases within the nebula, which emit light at specific wavelengths. Here's a detailed look at what causes these stunning hues: ionization and emission lines. When the central star of a planetary nebula sheds its outer layers, it exposes a hot core, often a white dwarf. This core emits intense ultraviolet UV radiation, which ionizes the surrounding gas. Ionization occurs when atoms absorb UV photons, causing their electrons to jump to higher energy levels. When these electrons fall back to lower energy levels, they emit light at specific wavelengths, creating the nebula's characteristic colors. Common elements and their colors. Different elements emit light at different wavelengths, resulting in the various colors observed in planetary nebulae. Hydrogen, H. The most abundant element in nebulae, hydrogen, emits a red light when ionized, known as the H-alpha line. Oxygen, O. Ionized oxygen often emits a green or blue light. The doubly ionized oxygen, O3, line is particularly strong and contributes significantly to the nebula's color. Nitrogen, N. Ionized nitrogen emits red light similar to hydrogen but at a slightly different wavelength. Helium, He. Ionized helium can emit light in the blue or violet part of the spectrum. Spectral lines and color variations. Unlike stars, which emit a continuous spectrum of light, planetary nebulae have spectra dominated by discrete emission lines. This means that the light from a nebula is concentrated at specific wavelengths corresponding to the colors emitted by the ionized gases. The combination of these emission lines gives each nebula its unique and often multicolored appearance. Factors influencing color. Several factors can influence the colors observed in a planetary nebula. Chemical composition. The relative abundance of different elements in the nebula determines which colors are most prominent. Temperature. The temperature of the central star and the surrounding gas affects the ionization levels and, consequently, the emitted colors. Density. Denser regions of gas can emit more intensely, making certain colors more vivid. Viewing angle. The angle at which we observe the nebula can affect the perceived colors, especially if the nebula has a complex structure. Artistic representations. It's important to note that many images of planetary nebulae are processed to enhance their colors. Astronomers often use narrowband filters to isolate specific emission lines and then assign colors to these lines to create composite images. These images highlight the intricate details and structures within the nebula that might not be visible to the naked eye. The journey of a star from birth to its transformation into a planetary nebula is a fascinating process that spans billions of years. Here's a detailed look at the stages involved. 1. Nebula, stellar nursery. Stars begin their lives in vast clouds of gas and dust known as nebulae. These regions, often called stellar nurseries, are primarily composed of hydrogen. Gravity causes the gas and dust to clump together, forming denser regions within the nebula. 2. Protostar. As the clumps of gas and dust continue to collapse under gravity, they form a protostar. During this stage, the material heats up due to gravitational compression. When the core temperature becomes high enough, nuclear fusion reactions begin, converting hydrogen into helium and releasing energy. 3. Main sequence star. Once nuclear fusion starts, the star enters the main sequence phase, where it spends the majority of its life. During this stable period, the outward pressure from nuclear fusion balances the inward pull of gravity. Our Sun is currently in this stage. 4. Red giant. When a star exhausts its hydrogen fuel, it leaves the main sequence and expands into a red giant. In this phase, the core contracts and heats up, causing the outer layers to expand and cool. The star begins to fuse helium into heavier elements like carbon and oxygen. 5. Planetary nebula formation. As the red giant phase progresses, the star becomes unstable and starts to shed its outer layers through strong stellar winds. These ejected layers form an expanding shell of gas around the core. The hot core, now exposed, emits intense ultraviolet radiation that ionizes the surrounding gas, causing it to glow and form a planetary nebula. 6. White dwarf. The remaining core of the star, now a white dwarf, is extremely hot and dense, but no longer undergoes nuclear fusion. It gradually cools and fades over time. The planetary nebula itself is relatively short-lived, lasting only a few tens of thousands of years before dispersing into space. Key points. Chemical enrichment. Planetary nebulae play a crucial role in enriching the interstellar medium with heavier elements contributing to the formation of new stars and planets.